Hello Year 7, this is lesson 8 in the energy booklet. In our last lesson I asked you to have a go at this homework number 3, so let's go through these answers. A Bunsen burner, the energy used to make it work. Chemical. The useful energy out. Light and heat. The wasted energy. There was some sound and some wasted chemicals. Chemical as well. The hairdryer, electric in. Useful energy out, I would think heat for sure. And kinetic, because the air comes out at speed. The big wasted part there is sound. Now washing machine, electric in. Useful kinetic energy, or useful energy is kinetic, and the sound is a big one. Probably you are losing heat to the surroundings as well. A catapult. Stored chemical energy in your body. The useful energy out. Kinetic. And elastic. Stored elastic. The wasted energy is going to be sound again. And a roller coaster. Probably electric. In, and the useful energy, you got an increase in GPE and you got a lot of kinetic. There will be sound lost, and due to friction there'll be heat lost as well. So we have, it's out of 15 as long as you've got one of the correct answers. So say for example with the hairdryer, electric, yes. As long as you had heat or kinetic, that is correct. And the one wasted type of energy would be sound there. So there's 3 marks. And there's 1, 2, 3, 4, 5. 5 times 3 is our 15. Give yourself a mark out of 15. Sankey diagrams and efficiency. When an appliance transfers energy, only some of the energy is usefully used, the rest is wasted. So we've got a light bulb here. If we've got electrical energy going in of 200 joules, then the energy that's coming out must also equal 200 joules. So the light energy must be 200, take away 140, that gives us 60, don't forget the units, joules of energy. So question 1, what is the value for the light energy out of this bulb? We've just worked it out. 60 joules. Remember, it's 200. Take away 140. Gives me 60 joules. What type of energy would be described as wasted? Heat. You don't put on a light bulb to warm up your house. And question 3, what type of energy is useful? Put it on because it lights a room up. Now then, Sankey diagrams are another way of representing the flow of energy through an appliance or a system. Complete this one below. So effectively what we've got is this. We've got a flow of energy. Some of it is useful. Some of it is wasted. These Sankey diagrams were invented by a chap called Sankey many years ago, probably in the 18th century, and he was looking at the efficiency of steam engines. They're very useful Sankey diagrams. So if we add information to it, electric energy in, useful light energy. And by convention, if it's wasted, it drops downwards. So this is wasted heat energy. And remember, these energies are out. Now, if you recall, the value for the energy in was 200 joules. Now, this width here is what represents the 200 joules. This width going all the way down here, this width. And it's this width that represents the useful light out. And it's this arrow width that represents the wasted heat energy out. And it's actually to scale. Let me show you, right? If you count up the number of small squares there, you'll find that there are 20. So each small square equals 10 joules. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 joules. 110, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100 plus 100 is 200 joules. Now, in the useful energy, we have got 1, 2, 3, 4, 5, 6. Multiplied by 10 gives us 60 joules of useful light out. We should, in this case, with the wasted heat, have 14 squares. Let's just go with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 small squares multiplied by 10 gives us 140 joules. Remember, energy in has to equal the energy out. Now, to work out the efficiency, it's a very simple calculation. The useful energy out was 60 divided by the total energy in, 200. Multiply that by 100 to get a percentage. And I'm just going to use my calculator. I'd like you to do the same. 60 divided by 200 equals 0.3 times by 100 gives me 30%. That light bulb is 30% efficient. So, from the efficiency calculation that you have just completed, what percentage of energy out was wasted as heat? You had 100% of the energy that went in. That was electric. 30% of it was usefully converted into light. So what was wasted? 70%. So the wasted heat energy . 70% 70%. Wow. Quite inefficient. Now, efficiency calculations. Let's have a look at these now. We can calculate the percentage efficiency of any appliance using this equation here. Efficiency, percentage, is the useful energy out divided by the total energy in and multiply it by 100. So, work out the efficiency of the new TV, which takes in 3,000 joules of electric energy and transfers 600 joules out as light and heat. Show your workings. The efficiency. I wonder if you could do this before me, so you can pause the video. Now, the useful energy out, 600, divided by the total energy that went in, 3,000. Multiply that by 100. And once again, use your calculators. 600 divided by 3,000 gives 0.2. Times that by 100 to get a percentage, and you should have got 20%. Have a go at this before I give you the answer. Calculate the efficiency of a vacuum cleaner that takes in 2,000 joules of electric energy. It wastes a total of 500 joules. Show your calculations. Ooh, this is a nice one. The total energy in equals the useful energy plus the wasted energy. If I put the wasted energy on its own, the wasted energy equals total energy, take away the useful. Oh, my mistake. We are trying to work out the useful energy here. So the useful energy equals total, take away the wasted energy, and that equals the total energy in was 2,000, take away the wasted 500, means we've got a useful energy of 1,500 joules. Now we can work out the efficiency. This is a GCSE question, this is. Efficiency percentage equals useful out divided by total in times by 100. That's the equation. Now we put in the workings. The useful energy. 1500 divided by the total energy in 2,000 joules, multiplied by 100 to get a percentage, and then we're going to get our answer. And our answer is 1500 take away 2000 equals 0.75 times by 100 gives us an efficiency of 75%. Difficult question. That is GCSE standard, that is.